Okay. In calorimetry, as I was telling you yesterday, it is about the energy that is necessary to raise the temperature of a substance by 1 degree Celsius. In calorimetry, we're going to be using the formula for specific heat capacity, which is this one. Okay, a specific heat capacity is equal to heat or energy divided by the mass and divided by the change in temperature. In this case, the temperature must be in Celsius. Now, this is the formula for specific heat capacity, but in this kind of exercises, in calorimetry exercises, we're not going to be using specific heat capacity, but we're going to be using the formula isolated for energy, okay, or for heat, okay? So how do we transform this formula into energy formula, energy equation? All we need to do is isolation of the part of the formula that is about heat or energy, okay? So the mass and the temperature that are dividing energy, they are dividing here and they're gonna go to the other side to multiply. So Q in the end, Q or energy is going to be equal to the specific heat capacity or CP, okay? The specific heat capacity times the mass of the substance times the change in temperature of the substance. And I gave you a table of specific heat capacities. So in this problem, we have what do we need to do? We need to isolate, we need to separate our given, into the substances that are involved. So for example, here, I have a metal bolt, it's going to be one substance, and the water is going to be the other substance. And then we organize the data according to what is given to us. So it says 0.05 kilograms metal bolt, that is the mass of the metal bolt. It's heated to an unknown initial temperature, that means that the initial temperature is unknown. Then it is dropped into a calorimeter containing water, which means the other substance is water. The mass of water is 0.15 kilograms. And this one has an initial temperature of 21 Celsius. The bolt and water, both reach a final temperature or the equilibrium temperature of 25 degrees Celsius. And this is important because in calorimetry, the two substances that are involved, they're going to share the same final temperature. So if the metal has a specific heat capacity of 899 joules over kilogram Celsius, find the initial temperature of the metal. I need to find Ti of the metal bolt. They are giving me Cp of the metal, but they're not giving me the specific capacity of water. So I see the table and I get the information about water here. That is 4.186 times 10 to the third power, or the same as 4,186. Okay, it's the same. 4.186 exponential 3 is the same as 4,186 joules over kilogram Celsius. So I drag this information from the table and I write it down there in my list of givens. Okay? Once I have all this, I need to analyze what is going on in the problem. What situation I have? What is the situation that I have here? Let's analyze. They are giving me okay? they're giving me a diagram. Sometimes they will give you a diagram, sometimes they're not. Okay, this time they're giving you a diagram. And we have a moment before and a moment after. Okay, we have a moment before and a moment after. Before, what do we have? We have the two substances apart. They're not together yet. But what do I know about the metal bolt? I know that it was heated. Okay, that's what I know. That the metal bolt was heated. So, what happens? Well, I picture in my head, I picture the metal bolt like that, showing that it's really hot. So what's going to happen? I'm going to place it into water. Why do I do that? Because I wanted to cool it off. I want to cool it off. Okay? So I put it into water. That's something that you already know. Okay? If you want to cool off something, you're going to use water. So you place the metal bolt in the calorimeter that contains water. And what's going to happen after? After, both the metal bolt, okay, the metal bolt and the water, they're going to reach a thermal equilibrium. That means that the temperature, the final temperature of the two objects is going to be the same. Okay, now I don't have a different initial temperature. Okay, now the two temperatures are the same. The two, the bolt and the water, they're experiencing the same 25 degrees Celsius. That is the purpose of calorimetry. The two objects are going to reach the same condition of final temperature. What is the problem asking me to find? It's asking me to find initial temperature of the metal. So in calorimetry, we need to accomplish one condition that says that the energy that is gained is going to be equal to negative the energy that is lost. And this is the most important step. So I want you to listen. Gaining and losing. So I'm going to give you a tip. The substance that is the hot sample or the hotter substance is going to be the substance that is losing energy. Okay, the substance, the hot sample. Okay, the hotter substance is going to be the one that is losing energy. And the substance, the one that is cooler, okay, that this one is the one that is going to gain energy. So let's analyze this problem. What substance is the hot sample? Water or metal bolt? What substance is the hot sample? The water or the metal bolt? Read the problem. It says a 0.05 kilogram metal bolt is heated to an unknown initial temperature. So what is the hotter sample?
The water.
What is the substance that is heated? The metal bolt or the water?
And the metal bolt.
It says the metal bolt is heated. That means that this object is the hot sample, okay? This object, the metal bolt, is the hot sample. Therefore, metal bolt is the one that is losing. So, this is your main equation. And this main equation is going to be transformed into, instead of Q lost, is going to be Q of that metal bolt. Why? Because it's the one that is losing, okay? Therefore, the one that is gaining is going to be water. Why? Because it's the cooler substance. In other times, my students used to say, Miss, I'm just going to memorize that water is the one that gains. And yes, most of the time it's going to be like that. The water is the substance that is gaining energy. Why? Because water was initially at 21 degrees Celsius, and then the temperature was increased to 25. So an increase in the temperature of water is telling you that is the substance that is gaining energy. It's absorbing energy from the metal bolt. Okay? That's why water is lowering the temperature of the metal bolt. That's why water is used to cool objects off. Okay? So gaining is going to be water. Why? For all the reasons that I told you about. Now, we're going to write the definition of Q that we isolated before. What is Q? Q is equal to specific heat capacity times mass times change in temperature. So this is going to be Q of water is going to be equal to minus Q of the metal bolt. And now you have your equation already transformed. But this is water, and this is the metal bolt. Okay? So you need to specify the two substances. Now, what do we need to do? We need to write the givens in the place that it corresponds. So, a specific heat capacity of water, it is in the table, and it is 4,186 joules over kilogram Celsius. Now, mass of water. What is the mass of the water sample? What is the mass of water? Look, I cannot project
0.15.
exactly. Okay, I cannot project all the whiteboard because it's too big. Okay, and if I project all the whiteboard, you won't be able to see the numbers. So you already have your data with you. The mass of water is 0.15 kilograms, and delta T of water change in temperature. Remember that is final temperature minus initial temperature, but of the water is equal to what I have in the other side. Okay, so what do I have in the other side? I have minus a specific heat capacity of the metal. What is the specific heat capacity of the metal? The specific heat capacity of the metal is 899. Joules over kilogram Celsius. What is the mass of the metal bolt? What is the mass of the metal bolt?
0.50, 0.050 kilograms.
0.050 kilograms. And the change in temperature of the metal bolt, I don't know it, okay? So I'm just going to write it here because this is the unknown, okay? So what do I need to do here? I need to start working with this exercise. How much is this multiplication? 4,186 times 0.15. How much is this?
627.9.
Okay, 0.9, okay? And these are joules in the top and Celsius in the bottom, because now you already cancel kilograms with kilograms. Now what comes after? I need to multiply times the final minus initial temperature of water. Okay? Now what do I know about water? The temperatures of water. I know that the final temperature is 25 and that the initial temperature is 21. Okay? So here is going to be final temperature of water, that is 25 degrees Celsius, minus initial temperature of water, that is 21 degrees Celsius. And this is equal to minus what I have in the other side. How much is 899 multiplying 0.05? How much is this? How much you got in this multiplication? I mean this one, 899 times 0.05.
44.85.
44.95. These are joules. I already canceled kilograms with kilograms. Celsius, multiplying my delta T of the metal bolt. Okay? Now, I continue. 25 minus 21 is going to give you 4. Okay? So this is going to be 627.9 joules over Celsius degrees multiplying 4 Celsius degrees. And this is equal to, as you said, thank you, Freddy, 2,511.6. Now take a look here. These Celsius are going to cancel out with these other Celsius. So it's going to give you just joules. Now the other side remains the same. Okay, this side remains the same. Over here remains the same, but I need to isolate. Okay, I need to isolate. So take a look. 44.95, what is it doing to the temperature? What is this number doing to the temperature? Is it?
Multiplying.
It is multiplying. So when you send it to the other side, it will be doing a division, okay? So don't get confused. This minus, it represents a subtraction. I know it, okay? But you are isolating Tm, okay? This is what you are isolating. And what the number is doing to Tm is multiplying. Here, between the two, I have a multiplication. So when you send it to the other side, it will be divided. So my isolation is going to be 2511.6 divided by negative 44.95. These are joules over Celsius. So in here, joules and joules, they're going to be canceled out. And in the other side, I'm going to have my delta T of my megavolt alone. How much is this division?
Negative 55.87.
Negative 55.87. 88 rounded, okay? 88 rounded. Negative 55.88 rounded. These are going to be Celsius degrees. And this is equal to delta T. But delta T, what is delta T? Delta T is final temperature of the metal bolt minus initial temperature of the metal bolt. I am looking for this one. Initial temperature is the one that I'm looking for, okay? If you go back to your data, okay, this is what you're looking for. Initial temperature of the metal bolt, okay? But you know the final temperature, that is 25 degrees. So make the corrections. Is equal to the final temperature, that is 25 degrees Celsius, minus Ti of the metal bolt, okay? And now you isolate. What is 25 degrees doing? Adding, subtracting.
Adding.
Is adding. So in the other side, it's going to be doing a subtraction. So you will have negative 55.88 degrees Celsius minus 25 degrees Celsius equal to minus initial temperature of the metal bolt. Okay? How much is this? How much is this?
Negative 80.88.
So negative 80.88 degrees Celsius is equal to negative initial temperature of the metal bolt. And because I have those two negatives in the two sides of the equation, we're going to cancel them out. So in the end, the initial temperature of the metal bolt is equal to 80.88 degrees Celsius. So the procedure is a little bit long. The procedure is a little bit long, but it's simple, but just you need to be organized. For example, in here, in the parentheses, okay? In this parenthesis, You can no longer continue because you need to perform whatever you have in the parentheses first. And also here, you need to be careful in this part because when you isolate it, okay, when you isolate it, remember the main operation the mathematical operation that is it doing is a multiplication, okay? It is multiplying t. How do I know that it's multiplying t? Go back to the main equation, take a look. See? In between, you only have multiplications. You only have multiplications. Only in this part you have an addition because of the definition of delta t. What is delta t? Delta t is final minus initial, okay? But that's the only addition that you have or subtraction that you have in the entire problem. But the main formula has just multiplications. These are multiplication symbols. So you need to be careful with that. Now I want that you see this exercise and tell me if you have a doubt in a specific part of the procedure. I will assign a homework so you can practice this topic. This and also Bernoulli. Remember that yesterday you told me that you didn't watch the video of the Bernoulli example. But I explained the topic, okay? So you have to watch it from YouTube if you want to do the homework. Remember to write this exercise in your notebook. Follow the guidelines for note taking. If there are no doubts, I'm going to end the meeting.